Hey guys, there were two other properties of logs. This was actually back from 4.3 that I wanted to mention, just in case I forgot. And that is that if we have a base raised to a log of the same base of x, that's just equal to x. And log base a of a to the x is equal to x. This one's a little easier to see. But to show why this is, okay, one way you can do it is to realize, if you recall, a to the x and log base a of x, these are inverse functions, right? Remember we said logarithms are just exponentials that make it convenient for writing the inverse of a given exponential function, okay? If they're inverse functions, we know that if we say f of x is equal to a to the x and g of x equals log base a of x, what that tells us is that f of g of x must equal x, from what we know from inverse functions, and g of f of x is equal to x. See that? So if that's true, let's see. F of g of x, that's going to be a to the log base a of x, right? And since we know they're inverse functions, it must equal x. That's sort of your pseudo proof for this first one. And g of f of x is log base a of a to the x. And we know that has to equal x if they're inverse functions. So there's the reasoning. So for example, if I have something like this, if I have 2 to the log base 2 of 7 equals x, here's a very simple equation, then I can say, oh, well, yeah, this right here has to be 7. Hence, 7 is equal to x. Or if I have something like this, log base 3 of 3 to the x equals 4, well, I know this right here just simplifies to x, and that has to be equal to 4. Okay, so I just want to mention that just in case I forget.